All right. So today, here's the question that we are going to try to answer. And in your notes, start a new page, title it. Let me go over here and actually add, we'll say chapter 7, sampling distributions. And we're going to start by asking this first question here. Okay. The mean age of pennies in the United States. Now, in order for us to calculate the mean of every penny in the United States, we'd have to find all of them, add their ages all together, and then divide by the total number of pennies. Is this something that could actually be achieved? No, because you have pennies that are pretty much everywhere, right? It's like glitter. I mean, they're everywhere, right? So this is a question where, for this chapter, these sampling distributions, we're moving away from probability. The last two chapters have been really sort of our probability tangent, if you will. I'll call it that. Now we're getting back on track to how statistics can be used practically. Now, this may not be a question that we feel like we want to know, but it is a good example, since pennies are readily available, for us to actually try to answer the question today. And we'll see how we do, okay? So to start class off today, we are going to be calculating the average age of pennies, all right? So I'm gonna explain how we wanna do this, and you guys are gonna grab your calculators and do this with me to start, and we're gonna explain what you're gonna be doing. You have 6 bags, and Hannah at home, you've got 100 pennies ideally. We're gonna break these into groups of 2 bags that have 5 in them. You'll see in Sharpie, they'll say 5 and 5. You've got 2 bags that say 15 and 2 bags that say 30. So all in all, you have 100 pennies gathered there, okay? These are our samples, 6 different samples, 2 of each size per person. So we're gonna get a lot of data here, okay? Now, let's say that this was your sample, what I have sharing on the screen. So everybody should be able to see that. And if I want to calculate the average age, what do we do? Well, it's 2021, right? And you'll notice here at the front, 2021 minus the age of this first penny, 1990. 2021 minus 2015, 2021, so on and so forth, to get the age. And I add all those ages together and divide by the number, okay? And I could sit here and I could have you do that, but obviously, you know me, we have to get a computer to do all this, make it faster, and that's what we're going to do, okay? So I'd like everybody to open up their calculator, and I've got to go, hey, I never gave you one, okay. Well, let's pull up those that have it, I'm gonna pull it over here, okay? And go ahead and open up a list and spreadsheet. See, any other distance learners? Nope. Listen spreadsheet. And this is how you're going to do yours, just to make it go faster, like when we start interpreting our sample, okay? This is just the fastest way that I've found every time. The first thing we're gonna do is we're gonna enter our years over here, or year of the penny, and then we're gonna enter the age, okay? Now, the first thing I would do, I'll pull up this PowerPoint again, is I'm going to type in all of these ages. So 1990, 2015, 2005, 2003, 1955. Okay. So what was the first one? 1990, 2015. Is that right? I don't remember them all. 2005. And then 1955, okay. All right, so that is the year. Now, how can we get the age in this column here? Using our little formula sheet at the top. Minus age, right? Equals, we'll do 2021 minus the age. And this tells us the ages. Oh yeah, that's circular, okay. Year, yes, year, sorry, year. Hit enter. There's all the ages of my pennies, calculated form. Now I want to find the mean age. How do I do that? 411, menu, 4, 1, and 1. And we want to use average age. That's what we want. So we hit OK. And we get 27.4, okay? So this would be the method that you guys would use when you're calculating yours. Let's say you go to your second sample. All you'd have to do is enter in the years of the new pennies. Let's say the next sample, it was 1993. I go down, 2004, 2020, 2018, and then we have 19, we'll say 83. Okay, it automatically will recalculate your mean for you without having to do all that work. So now my next group is 17.4 years. Okay, does that make sense? This is what you're going to be doing. Now, you're going to set up your notes a particular way for me. And you may, you're going to set up your notes like this. Now, you'll notice that I've written them up. And you may want to turn your notes to the side, or you can actually do this probably vertically. You're not having to write a lot here, okay? You're going to write out n equals 5, n equals 5. These are the first two bags. So we're going to go ahead and set up your notes like that. You're going to find the mean. And then you're going to repeat that twice over here. You're going to do this twice. You're doing 15 twice and 30 twice. You already have the bags preset. Normally what I do is I put these in a bucket and I have students pick them out, their own samples, but obviously with COVID, we can't do that, okay? So we're calling these, just by the way, we're calling these random samples. We'll bring that up later on, whether they are random or not. We'll talk about that because that is important. But what I'm gonna have you do is we're gonna go ahead and take a few minutes, and Hannah, you'll do this as well. Please go ahead, you're gonna take out the pennies one at a time from the bags. You will calculate the mean for each bag. That's what you're gonna do, each sample, all right? I gave you a glove, so you can use that. If you feel like you want a second glove, I don't really think you need to, but if you feel like you need one just because you feel icky, I can bring you another one, okay? So let's go ahead and start calculating those. And Hannah, you do yours at home as well so that we can use your data, okay? So we'll give a few minutes to do that. And we'll do some dynamic camera work here where you can see everybody. Everybody give us a wave. Yeah. Well, you're going on Play Positive as well, so. Yeah. YouTube will be unlisted, so don't worry about that. No, Henry goes off screen now. What did you say?
I said thank you for not joining class today.
Oh my gosh. Mm-hmm. Oops. What'd you say?
I somehow ended up putting it in the schools.
Wait, we already did it.
No, mine doesn't count. Mine does not count. Mine was an example.
What's y'all's oldest one?
Yeah, I can't remember what the oldest one
I can't even see.
is. Hmm?
Okay. What was that?
That was my timer. I'm about to throw it away.
I can't see any of these.
What? Are they just dirty?
No, I'm just one.
Where's your glasses?
Oh, they broke. My new ones come this week. Don't worry.
All right, here's your strategy. Henry.
I just put all 6 in mine.
Look like
Yeah,
I
you got
just.
6.
What did you do? I don't think you did anything wrong. You have 3 averages per.
Yeah.
You have the
Oh.
All right.
No, I thought.
No, I don't know if that really if it's so wrong.
All right, y'all. So we're going to go ahead and start the second part of this. And you will need your data. I would, you're going to draw this next chart in your notes because we are going to plot our data points. So please go ahead, draw 3 lines in your notes. And if you want to start a new page for this, you can do that. And I'm going to go to each person in here. And Hannah, if you already get yours, you want to go ahead and type yours in the chat. I need to share the screen. Okay, there you go, Hannah. So if you want to, I'm going to go around the room and we'll have Hannah also have hers in here. We are going to, I'm going to ask for your means that you calculated. That's what I want, okay? This is going to be our first sampling distribution that we've made in this class. We've done distributions before. For instance, when we did the experiment with the chocolate, we made 2 distributions and compared them. That's a sample distribution, but this is going to be a sampling distribution. So we'll talk about the differences between those. And understanding the difference between a sample and a sampling distribution is going to be huge for your success in this chapter, okay? Huge. So Hannah, you can go ahead and start typing in your averages. You should have 6 different averages. I need the ones for, let me go to my screen here. I need yours for n equals 5. So you'll type in there. Okay, so is that in order? So those are 5, 5, 15, 15, 30, 30. Is that how that is? Also my Zoom is frozen. Yeah, it's in order. Okay, perfect. So I'll get yours in a second. But let's go ahead and start in here because I'm going to plot these up here. I'm going to use I'm going to draw, and you are going to also draw this in your notes as well. Okay. Make sure this is a little bit bigger. So we'll do that. Okay. So the first thing I'm going to do is I'll start with Evan on this one. And I just want you to give me, for now, one of them because I want to talk about this. So what was for your first set of 5, what was the average age of that sample of 5?
Wait, like, just like my very first set of my
Yes, that's right. 36.78. And let's round that up. Everybody round up there, round to the nearest whole year because I want to keep these, I don't want decimals. So that would be what, 38? 37. Okay. So everybody's going to put a dot. We're making a dot plot here. So 37. So we'll put that on here. If I can even get it. Okay, there we go. That did not work. Why is this not drawing? Wow, what is happening? Hold on. It's so laggy. Hold on. I gotta get this figured out. Okay, so 37. Please draw. Dude. I don't know if this is gonna work the way that I hoped it would. Maybe this one will work. Yeah, this isn't it. Okay, let's find another way here. Hold on. We're trying to put this point at 37. Let me see if this works. Oh no, it did not work. I'm having I'm trying to think how I'm supposed to get this done without having to, because I want Hannah to be able to see it, but I also need y'all to be able to see it. Hold on. Yeah, anybody have any ideas about why it's doing that with this line? Or why is it doing that?
Maybe are we dragging?
Actually, I know what to do. I'm going to move this over here. Hold on. I'm going to stop sharing. Do some computer work here. Share screen. This one. Okay. Okay, that's fine. All right. So we're just going to make this happen. All right, so this should work now. So we're going to put that at 37. All right. How's you took the SAT?
You miss all the fun.
Ah, we have a dot. We have a dot. Okay. We did it. We did it. First dot. Okay. So here's my question. Does this one dot answer this question?
No, because the sample is way too small. And it's just one try, right?
Okay. So you're saying the sample's too small and you said it's just one try. Okay. Now I'll go ahead and tell you that we could get pretty close to, do you think that this number that we got 37 is close maybe? Maybe close. Okay. Well, let's go ahead and plot some more. So Evan, give me your other one. Yeah. Give me your other 5. 31. Okay. So that's quite a bit different. All right. Go ahead, Madison. What are your 2? Okay. And 23. All right. So right away, the idea that Evans might be close is kind of, we lose confidence in it, right? Because now we have Madison's, which is 16. And that's a pretty big difference. That's, 21 years difference. There's a lot of what we'd say spread, right? Like the range right now is pretty large for this. I don't think we should feel confident about any of these. So let's go to Braxton's.
My first one is 10, my second one is 12.
10 and 12. Wow. Young averages here. Okay. Still lots of spread compared to Evans. Evan, that was a very old sample that we're starting to see now. It might be one of the oldest here.
Just a little bit.
Yeah. Henry, what are yours?
21.
21 and 24. Okay. What do you got, Morgan?
27 and 23.
27, 23. So we'll stack those. All right, Alexia, 20 and 12. Okay. CJ,
34.
30 and 15, 16. Okay. Go ahead, Carter.
17 and 5.
Okay. 5 is not on here. We're just going to put 10. Oh, no, we'll just put it down here. Okay.
We just do like a really big outline on that.
Yeah, we could. We'll just put it to the left. That'll be fine. That's where those go. Go ahead, Mackenzie. Yeah, for sample size 5, the first 2 averages.
I got 42.
42?
Yeah.
God,
I don't know.
that's fine. I mean, I believe it.
Okay.
5 old pennies.
And 23.
23. Okay. And then I need to go back and grab.
Yeah, I'm just gonna skip 8.
The screen is in the way. I'm so sorry. Go ahead. What are yours?
22 and 23.
22 and 23. 22 and 23 are hers. And then we'll grab,
Yeah, you're writing this in your notes. So, oh, Hannah had 3. Okay, 17 and 3. So we'll just put that one up.
She probably got 2020.
Maybe so. They were from her house, right? So 2017, but it doesn't matter. We'll put it in there. Get them involved. Okay, wow. Yeah, so this is very spread out. And if you look at this individually and you take your individual points, everybody's everywhere, right? We don't really have a confident answer for this, like what is the average age? But if we had to have an estimate, what would be our best guess for the average age? Why 23? That was a mode, right? But we don't always use the mode as like our center, right? So we have a distribution here. What our best guess would be the center of it, right? So we talked about SOX, right? Center, or excuse me, shape, outlier, center, and spread. This is very spread out for that last S. But what is the shape of it? You think it's skewed to the right? You do have more over here to the left. Obviously, this isn't to scale, so these would be further out. But yeah, right. This isn't to scale. So it might be, I don't know, it might be symmetric is more, I don't know about uniform. Uniform means flat. Symmetric, right? What is the center? Where's that balancing point to this? It might be 23, okay? 23 might be that balancing point. And that would be probably our best guess. So those of you that got 23, your sample might be the closest to this true answer. Everybody else, it's just so spread out. We really can't trust any one sample to make this decision, okay? Let's go ahead and continue. Let's do samples of size 15. So we'll start back with Evan on this. So what are your 2? 31 and 27, okay? Go ahead, Madison. Okay. Braxton. Okay. Henry. 19 and 30. Okay. Morgan. 27. Okay. Alexia. 15, 28. CJ.
22.
Okay. Sorry, Carter. 14 and 20. Mackenzie. 22 and 19. Okay. I got you this time, Crystal. 25 and 16. All right, then we'll pull up Hannah's. So she got 20 and 19. So 20 and 19. All right, cool. Ooh, big difference here, right? What do we notice happened? Yeah, we see a lot less spread. And if we think about that, and Evan, you're saying, would we trust our values from that first? We said, well, the sample's not big enough, right? What is happening here is as we increase this sample, we're getting closer to what the true value should be, right? Where's the average on this one? Where's the center? What do y'all think? 22, 23. It's still pretty close to what it was, actually. So this one was still kind of accurate. We definitely didn't get as many extremes, okay? Because the true average will show itself if we have more and more in there. You don't have, what is causing this spread to happen? Like 42, is that yours, Mackenzie? The 42, right? Yeah. What was your youngest penny in that set? Do you remember? My youngest?
Yeah, in this one. 2014, that was a 6-year-old penny. That's crazy that, that one penny, imagine if that hadn't been in there, this would be way older. That 6-year-old penny, that brought this one down. But these are so susceptible to being pulled all over the place based on what's in there, right? But as you increase the sample size, we're seeing much more consistency, if you will. Let's get the last set here. Evan. 25. Oh, 35. And what?
Good grief. Those are pretty old.
You're telling me.
Yeah, I know. This is counter to what I was just saying, isn't it? Unless this is the true age, but we'll talk about that later. Madison? 19 and 22. Okay.
19 and 18.
19 and 18. Okay. Henry? 21, 23. Morgan? 20 and 22. Okay. Alexia? 20 and 25. CJ? 21, 25. Go ahead, Carter. 20 and 22. Kinsey? Wow. Okay. Crystal? Okay. And then we get 23 and 20. Okay. So 20 happened quite a bit there. Evan, I don't know what happened there. Like you, that almost deserves a recount because that's so different than what we're seeing. It almost seems like something went wrong. It's too unreal.
I had some of my older, younger
Yeah.
buddies,
Interesting. Go back and we might change that. Yeah, that seems too unbelievable. Too unbelievable.
It doesn't matter.
Yeah. Okay, so we see this pattern continues, right? That's some of the things we're going to write down underneath this. Let's talk about the patterns that we're seeing in these distributions as we're going through this. Okay. The pattern that's happening here is as we increase the sample size, we're going to go ahead and call it this variability. That's going to be one of the words that we need to learn. It's a term. I'll also put spread is reduced. Okay. That is one of the, I guess that's kind of the main pattern that we're looking for. All right. Anything else that we notice about this? I definitely want to wait till Evan gets his recalculated. Did you write them down or did, oh, you did good. Okay, so I'm glad that y'all did that. While we're waiting there. Oh yeah, got a pattern. There we go. I'll even add this of the sampling distribution is reduced. Okay. Okay.
Yeah, I still got the same thing.
No way. My mind's blown. I just, like, honestly, it just doesn't make any sense that it's because it's so far from our pattern of what should happen. But, you know, crazy things happen every day. So we can, we'll let it fly, I suppose. Wait, is the other one different?
Let me check the other one, I guess. The first one is the same.
Okay.
It was weird.
All right. All right. So we'll go back to this and we're going to draw some lines on our graph here. I want to do this. I'm going to pull up this ruler and we're going to draw some vertical lines. Now we said that the mean of this first one was about 23. So what I want everybody to do is we're going to draw I'm going to draw it in blue, but we're going to draw a line. That's too big. Hold on. I'm going to draw a line going through there, and we are going to label this as we're going to give it this symbol. Okay. And this is mu of x bar. Okay. This is the mean of our means. Because every dot on here in this first one, somebody tell me, what does one dot represent? This, let's just say this one right here. Whose dot was this? This 31 on the first one. Who had 31? That was you? Okay. What? Well, you're busy. Okay. Well, actually, no, somebody else interpret it. This is Evan's dot. What does this dot represent? One average of what? It's one average of the, yes, the distribution of 5 pennies. It is the mean of a set of 5 pennies, right? And every single dot on here represents what? A mean, right? We could write every single one of these as X bars, right? Every single one. They represent X bar. And I could write that all over these. You don't have to do that, but that's the idea here, is that these are what this blue line represents is it is the mean of the means. So it's like this compounded idea of, okay, I'm taking the average of these averages. So we have that one there. Let's draw the other one. Where was the center? Where did we say on the second line? Sample of 15. Where do you think that balancing point is on this? 22. Yeah, I think we said that, right? So 22. So I'm going to draw another one. And you'll notice that it's pretty close to, I need to draw, here we go. It's pretty close to the one that we had, okay? So this again is, we're gonna put mu of X bar on there. 30 what? We'll go for it. All right, we move that dot down. All right, so we still have that mean. Now, Evan's outliers here kind of throw off our center a little bit. They're gonna pull it down, but what do we think about the last distribution? 22 still? Yeah, probably. So we'll just line that up. Move that over. So 22, we'll draw one more. Right there. Okay. So that's the last one. This is the mean of X bar. What's that? So you were on the mean that we have. So what is our best guess for this question here? If we had to answer it. Huh? 22, well, we want to go with the center, right? The mean of them. Because we took all this data here and we say, well, if we take the average of these averages, there's going to be variability, but the average of those should be close to the true mean of that age, the true age of the pennies, okay? So with that, we're going to put I'm going to put a red line, okay? So we're going to guess that I'm going to line it up here. I'm going to draw one red line all the way across this slide. Okay, all the way down. And this red line represents the actual mean, okay? So we use the symbol mu for that. Now, which one was the only one that didn't do it correctly? The smaller sample, right? There was too much variability. So our blue line was off a little bit. Sorry, I'm standing up and the camera doesn't look good on that one. Yeah, I get very passionate about it, you know? So what we have here is called, we're gonna draw an arrow to that. This is called bias, right? Something in the sample has caused it to shift, and we know why, right? Because the sample is too small, okay? Now, what if, because I don't know the answer to it, I'm gonna draw in another color and you don't draw this one, but this is a what if. What if we actually Googled, which I tried and I couldn't find it. What if we actually Googled and we found out that the actual age of pennies, let me go with, we'll go with yellow. Nah, we'll go with dark green. The actual age of pennies was this green line, okay? And now none of our examples are actually accurate. So this is this is a large amount of bias in every sample. And that's something that we have to discuss next class. I can tell that we're out of time, but we're going to talk about the causes of bias in the situation. So my distance learners, that'll be something that I talk about in the lesson following up to this. Okay. So we will go ahead and end that there. Anna, thanks for participating. Have a great day. You do not have to watch the play pause. I'm going to go ahead and end the meeting.